Okay, so today we're going to be talking about angles and congruence. Okay, so two concepts. Okay, first of all, to build an angle, we need to talk about some basic pieces and shapes within geometry. So a ray is a part of a line. Okay, it's like if you think about the sun. Okay, so if you start with the sun and you're like, okay, the sun has different rays that start at the sun and then they go forever in a straight direction. Okay, and you might get a nice suntan from them, etc. It's not the best sun in the world, but you kind of get the idea. And so a ray has an endpoint, a starting point, and it goes forever in one direction. Okay. And so if you want to talk about this ray overshown here, okay, this one starts at M and it goes forever. And how you can name it is you're going to say it starts at M and it goes, and you pick any of the points for the direction of where it goes. Okay, if you go on the highway and you get on I-35, you might head towards Kansas City and you'll be going north. Okay, or you could head south and you might be heading towards Wichita. Well, the thing is, I-35 doesn't stop at Kansas City and it doesn't stop at Wichita. If you go south, it actually goes nearly all the way to Mexico. Okay, and same with going north, it goes not just stopping at Kansas City, but it goes through Des Moines and it goes all the way up to like Minnesota. Okay, so it's crazy forever. So you have to say where it starts, and that goes underneath the point side of it. That underneath the arrow is just any of the points, the direction of which you're telling it to go. Okay, so it could be MN or it could be MO. You just have to give it a point that tells which way you head. Okay, and so that is going to be something that you do. Okay. And so if you didn't mean this entire ray, well, then tell me where you want me to start. Okay. You could talk about another ray that starts at N and it goes towards O forever. Okay. Okay. And that ray would be this part of it. Okay. Okay, but you have to say, where am I starting and what direction am I going is a second point. Okay, the one that's underneath the dot is where it starts. And then the one that's underneath the arrow is which way you're headed in the direction. So opposite rays have the same starting point. I would say it's like a dual. Okay, so if you both start at J, so one of your rays is J towards K forever. Okay, and so how you write that would be, I'm going to start at J and I'm going to go towards what letter? I'm going to go towards K and keep on trucking forever. Okay, that's JK. Now, the opposite ray would be starting at the same location, but heading the opposite. Okay, it has to make a straight line, so it has to be a collinear. Okay, but if you have an opposite ray, it starts at the same point and it heads exactly the opposite way. Okay, from it towards another point. Okay, and so kind of like that I-35. You can head north and go towards Des Moines, or you can head south and go towards Wichita, but they make the entire street. Okay, so a straight line. And so JK would be one ray, and then J towards H would be the other one. Now, what you've got to be careful about is this. When I was little, I always thought that the arrow showed which way it looked like on the paper. No, it's not a directional hint. It's actually just, it tells the letter towards which it goes. So JH looks like it goes to the right on my paper. You're like, but silly girl, that it goes towards the left. No, it just tells us it starts positionally at a J and it goes towards H. It doesn't coincide with which the graph, the ray actually goes. We're just saying the letter towards which it goes forever on its way towards forever is towards H. So you really have to be alert that just because the picture or the name says, oh, it looks like it goes to the right, doesn't mean in the diagram it goes that direction. So it's kind of a little bit of a grumpy thing, but opposite rays form a straight line. Okay, they have to start at the same point. So notice J is the starting point on both of them, and they go in opposite directions from each other. Okay, so they make a straight line. And then, which is also called a straight angle. Okay, we'll talk about what that means. Okay, it's when, or even we'll pick it up in just a minute. Okay, so that's opposite rays. An angle is formed by two rays that meet at a common endpoint. So if you have a ray that's XY, okay, so that's going to be a ray, and that's the side of it, okay? So this is comprised of the sides, the rays, so that would be XY, would be one side. The other side would be the other ray that forms it, okay, so that'd be XZ, okay? And they have to meet at the same vertex, okay? So they meet at X, so the vertex is at X. Okay, and the angle is the the angle that's formed between them, okay? And how you can name it would be this, okay? So let's talk about, you can call it angle, and this is a little tricky. Basically, you follow this, and I'm going to get my highlighter out so they can watch me. So you follow it to make like a C. So you start at a point on the first ray, so it'd be X. Then the second point is going to be the vertex, which is, so YX, I said that wrong. So YX, and then you do another point on the second ray. So it'd be YXZ. So angle YXZ. It has to be to make like a C. So a point on the ray, the vertex, and then a point on the other ray. Or you could go backwards around it. Angle, and you could start at, I'm going to grab another color just so you guys can see what I'm doing. I'm going to grab green. So you could start at Z, X, Y. ZXY would be another name to write, to name it. So you start at ZXY. The middle term, the middle letter has to always be in the middle. Okay. Another way that you can name it, okay, is actually if there's only one angle next to you, you can just name it by the vertex, angle X, okay, which is kind of weird. And then another way to name it is if there's a number inside the angle. See how this says angle 2? You can call this angle 2. Angle 2. Okay, so sometimes you have to use the most formal way, which is using 3 letters. A point on the ray, a point the vertex, and then a point on the other ray, or around the angle the opposite way. Or if there's only one angle in sight, you can call it by its vertex, angle X. Or if there isn't a number inside of it, you can say, oh, well, I'm going to name it by the angle 2. So it's kind of weird. So let's look at this. This next one has 2 sides. One side is this ray right here, angle AD. The other side, okay, that makes it is going to be AB or AC, okay? The vertex is going to be angle A. And then how you could name it would be angle, and you would do DAB. Notice the middle value, the middle letter is going to be the vertex. Or you could go backwards. You could do it like B or C, and then you could do A and then D. Now notice there is no angle named in the middle, so it's like not like angle 3, angle 2, whatever. You might be able to call it angle A because there's not really another angle there. Okay. And let's try drawing angle ABC. How do we draw that? Well, the middle value is B, the vertex, and then you got to draw 2 rays. One is going to be BA, and the other one's going to be BC. How do you know that? Well, you have to go around the shape to be angle ABC. The middle one is going to be the vertex, and then B goes towards one ray to go left, and the B goes towards C, which is the other ray. So that is going to be what our angle looks like. Now we've named them. We've talked about how you make them. Now we're going to talk about how you give a name based upon the size of them. So if I say, what is, so if this is the angle DAC, okay, the measure of this is numerically how many degrees it's going to be. Okay, so we're going to look right here and say, okay, this measure of angle A. Now notice they named it by its vertex because there's really only one angle right there. So the measure of angle A is 90 degrees. If it's a 90-degree angle, it's a right angle. The little box there shows that it's a right angle. if you have an acute angle, that means this angle is from 0 up to 90 degrees, but greater than 0, but less than 90 degrees. So the value of B, the measure of B, has to be less than 90. And if you walk this way, you see the big end is going to be greater than 0. If it's obtuse, it's going to be less than 180, but greater than 90 degrees. So between those two values. And then if it's 180 degrees, it's like a completely open angle. It's going to equal a open book. It's 180 degrees. So that's called a straight angle. So it's a straight line, but this angle right here is going to be 180 degrees. Okay, I told you before, congruent means the same shape and size, right? Okay, let's write that down. Congruent means same shape and size. So if you see two angles, yes, those are the same shape and they have the same size as each other, we know they're congruent. Now notice we could say angle QTR is congruent to RTS if they are equal in size. Are they the same shape? Yeah, they're both angles. Are they the same size? I guess if they are, then they will be congruent. So if this angle matches the measure of this angle here. So notice they have the same amount of, like a same measure on there. You can put, like, if you see an angle, if you put like 1 mark, or if you put 2 marks, or if you put 3 marks, that shows that it may be congruent to another one. So notice these both have 1 arc here. So therefore they are said, hey, they are congruent. They're the same numerical measure. Okay, the same shape and the same size. A bisector, the word bisect means, bi means chop in half. So if there is a segment, okay, or an array that chops a bigger angle in half. So once upon a time, there's a big angle here. If these two pieces get chopped in half, that means they are going to be congruent to each other. So if it bisects it, means the two angles that are the one at big angle is chopped in half into two congruent pieces. So the word bisector means something gets chopped in half. Okay, there are two congruent pieces as a result. Okay, so there's some concepts. Let's do some questions. It says, try to answers 1 through 3. Okay, the first one says, name all the angles that have angle B as a vertex. Okay, so there's angle B, or they have B right there, okay? And so we can name, let's talk about naming a couple of these. So let's talk about this one right here. Okay, so one way we can name that would be angle 7. Okay, we could call the first one angle 7, or we could call it angle ABD. Does it matter which one we do? Not really, but that's one of the angles that has B as a vertex. Okay, that's right here. Angle 7 is also known as angle ABD. Okay, if we want to name this one right here, we could call it angle 6, or we could call it angle DBE. Okay, so that's another way to name number 6. Okay, so here's angle 6. Okay, let's name this angle on the left. Okay, angle 5. Okay, so let's talk about angle 5. Or can we give it another name? GBE. Okay, so you need 3 letters. One on the first ray, one in the vertex, and one on the other ray. Okay, and then the one at the top, that doesn't have a nickname. Okay, so the one at the very tippity top that has a vertex of B, we could call it, we probably just have to give it one name. So we'd say angle GBA. Okay, notice each of these who have a vertex as B, notice when you name them, B is in the middle of when you name it. Okay, it just happens that way. Okay, that's how you do it. So those are the 4 angles that you see that are going to be named there. Okay, so then let's talk about the sides of angle 5. Okay, so angle 5 is right yonder. So I'm going to get a nice color. So this is angle 5. So this is one of the sides. And so let's name it. So it would be ray BG. So it starts at B, the vertex, it goes towards G forever. The other ray is right here. So it goes B and it goes towards either E or F. Okay, so it starts at B and goes towards either E or F. It doesn't matter which one you say. Okay, so the two sides are the rays that form that angle. So angle 5 is formed by those two angles. Write another name for the angle 6. Okay, angle 6. Okay, we already kind of did that, didn't we? Angle 6, we can call it angle FB and then say D. Okay, so you have to start with a point on this ray. And then you do the middle, the vertex, which is B. So B has to be the middle one, okay? Because the vertex of angle B or angle 6 is B. So either E or F. Hi, Kitty. Are you losing your mind? So either F or E, and then you do B, and then you would go over here to go to D. Name a point on the exterior of ABD. You're like, what is that? Okay, so if you talk about, I'm trying to see if I've got, the interior is kind of between those two angles. The exterior would be outside of there. I used to have, I believe, a picture of interior versus exterior, and I don't know if I've got that here. Okay. So let's grab this. So a point exterior to angle ABD. So where's ABD? So I'm going to erase some of this stuff. Okay. So you got ABD. So ABD is right here. That's angle 7. So the thing is this, and this is something we should talk about. So on this is the on the angle part. The purple part is interior of it. And then outside of it, it's kind of like if that's a little mouth, you'd be like, oh, this is the actual mouth. The green part is actually the mouth. The pink part is inside the angle. And then outside of it would be anything outside here. Okay, so name a point that's exterior outside of ABD. Okay, so interior would be like right here. Okay, exterior would be outside of that angle. Okay, and so exterior of that would be like point E. And then interior of angle 7 would be like R. Okay, so inside like the mouth of that angle. So between the two angles are the rays that make it. Okay. And then let's classify each of these as right, acute, obtuse, and let's look for a straight angle. Okay. So the first one says MJK. So I'm going to kind of follow this along. So MJK starts at here, goes from M to J, and then it goes to K. Okay. The truth is that right here is 90 degrees. And the other truth is that this right here is a straight line. So if this is 90 and the straight line makes 180 degrees, then this has to be 90 degrees as well. So if MJK is 90 degrees, we call it right. Okay, so again, notice this right angle here shows this side is 90 degrees. That means this side is also 90 because they make 180 degrees or a straight angle. LJP, so let's check it out. LJP that's going to make an obtuse angle. Why? Because it's greater than 90 degrees. And then MJN is going to be acute because it's smaller than 90 degrees. Okay, and then which one is straight? If you would say straight, a straight angle makes 180 degrees. And in this case, the name of the straight angle is angle KJP. And that makes 180 degrees if you did this whole line right there, the whole angle. Okay, so then let's talk about the dimensions, okay? So we're going to use the sum of the parts equals the whole. So if ADC, so that's from A to D to C, that means this entire angle here is 115 degrees. And ADB is equal to 3x plus 12. And then BDC is going to equal 4x minus 2. And so they're like, can you write an equation that find the value of x? Well, of course we can. The sum of those two angles here, okay, so this little angle here, plus the sum, plus the value of this angle here, equals the overall angle right there. Okay, the sum of the parts equals the whole. So that works for segments, that works for angles. So if you go 3x plus 12 plus 4x minus 2, that equals 115 degrees. And so if we combine like terms, we get 7x plus 10 equals 115, minus 10 from both sides. You get 7x is equal to 105. Divide by 7, x is equal to 15. And then 15, it's not degrees, it's just 15. Okay, so if you needed to, you'd be like, okay, then what is the measure of angle BDC? Well, if they're like, find this angle or find the other, like, okay, well, if you know x, you would do like 4 times 15, which is x, and subtract 2. That's 60 minus 2, that's 58 degrees. Okay, and if they're like, oh, find the one up here. Okay, well, 3 times 15, which is x, and add 12, it's 45 plus 12 is 57 degrees. And if you take your calculator, I'm like, let's check and see. Is 57 plus 58 equal to 115? Yeah, it is. So it didn't ask you to find those two angles, but at some point I'll ask you to do that, and it should actually work. So the sum of those two partial angles equals the entire angle. Now the next one's a little weird to talk about. So let's look at it. If Z is on the interior of angle WXY, so you have to draw WXY. So let's draw an angle. So if it's W and then X is the vertex because that's the middle letter, and then Y. And then they're like, okay, Z is in the interior. So you draw point Z is inside of that mouth. Okay, so this is like a mouth. And then inside that angle is going to be point Z. And they're like, okay, connect it. They didn't say connect it, but you should. Okay, and they're like, okay, if the measure, notice M means measure of WXY is, so WXY, WXY is this whole part. So WX and then Y. So the whole angle is equal to 5x minus 58. If the measure of YXZ, so YXZ, that's one right here, is going to be x plus 1. And then if WXZ is right here, that's going to be 2x. I said find x, and then also find the measure of YXZ. So the sum of those two parts, the little parts, so 2x plusing x plus 1, gives you the entire angle, 5x minus 58. We're going to solve this by combining like terms. 3x plus 1 is equal to 5x minus 58, minus 3x minus 3x. So 1 is equal to 2x minus 58. Add 58. So 59 equals 2x. So x is equal to 29.5. Okay, so yes, it can be a decimal. And they're like, use that to find the measure of YXZ. So let's find YXZ. Okay, so YXZ, that's right here. So to find that, you do x plus 1. So x is 29.5. And you're going to add 1. So that's 30.5. And that's going to be in degrees. Okay, so you find x by adding the two parts and equaling the whole. Okay. The next one's a little tricky, but let's think about it together. Okay. The measure of AEB is 6x plus 1. So AEB, so it's this part right here. A to E to B is going to be 6x plus 1. And then CED, that's this part right here, is x plus 9. Okay. And then it says, find the measure of DEB, Deb. So DEB, they must have found this length right here, this arc right there. So D to E to B. Like, I can't do that. I'm like, yes, I know. We'll get it in a minute. So my question is, if I know this part And if I know this part right here, how can I find this part up here? Do you remember we talked about straight angles 180 degrees? Okay, and so the question is, oh, I didn't mark this right here. So this right here is 6x plus 1. So that's how you find this one right here. So what's true about the sum of these three parts? Well, they're 180 degrees because they're a straight angle or linear pair. And so we're going to take 6x plus 1 plus. Okay, I just looked at my key and I'm like, how did I get that on here? Okay, let's rewind ourselves just a half minute. Okay, let's do this here. So it says they're opposite rays, yes. And notice what I didn't catch, okay? I just started writing things. EB bisects AEC. So EB right here, this bisects this angle right here. So that's how we know if it chops it in half, that means that both of these angles right here have to be equal. Okay, so if we know this part down here is 6x plus 1 and it gets bisected, that means this big angle gets chopped in half and that both these angles have to be the same measure. So that's why I was missing it at the beginning, but let's reread it and make sure you guys have this. So we were given this one here, and we were given this one here, and then we're given the fact that this segment right here, the red one right there, bisects this bigger angle right here. So that means those are equal. So we can just easily say 6x plus 1 plus 6x plus 1 plus x plus 9 equals 180 degrees. And because they make a straight angle or a linear pair. And so we're going to add these up and we're going to add like terms. We get 6 and 6 plus 1 is 13x. And then add up the numbers, 9, 10, 11. So plus 11 equals 180. Minus 11 from both sides. Okay, and that equals 169. Divide by 13. X is equal to 13. Now they want us to find angle DEB. Where's DEB? DEB is going to be this part right here. It's kind of a lot. And so what we're going to do is we're going to say DEB is going to be 6x plus 1 and x plus 9 together. Okay, so it's both of these angles together. DEB is both of those things. So if we want to figure out the answer, we're going to find DEB. We're going to add up like terms. We get 7x plus 10. If we know x is 13, we're going to do 7 times 13 and add 10. And so therefore, our answer is going to be 101 degrees. So they kind of put a couple of things together here. We talked about bisectors. We talked about finding a big angle. We talked about a straight angle, which makes 180 degrees. And there we go. Well, thank you so much. I hope you guys have a great day.